So it's a bit hard to come right in the middle of that, right towards the end of that first movement of Tchaikovsky's Piano Concerto, but nonetheless, that's what I was listening to. As I started this video, the curve, y equals x cubed. This is a graphing question from the end of the chapter 4 review, is it? Where are you? Chapter 4 review. Chapter 4 review. I suspect I've been asked this question. I've spotted a mistake here. That should be a cubed there. It's just a typo. The curve y equals x cubed plus x squared minus x plus 2 is graphed to the right. The points P and Q are stationary points. Find the coordinates of P and Q. Okay, well, we're looking for stationary points. Stationary points at dy dx equals 0. Dy dx equals 3x squared plus 2x minus 1 here, which you can factorize as 3x minus 1x plus 1 equals 0. Is that right? Plus 3, yep, that's right. Okay, therefore x equals a third or negative 1. Y equals, well, we're going to have to sub it in, so that's going to be when x equals a third, y equals 1 over 27 plus 1 over 9 minus 1 over 3 plus 2, which is 1/27 times 1 plus 3 minus 9 plus 54, which is 54, 58 minus 9 is 49 on 27. Sure, so a third, comma, 49 over 27 is the point P. That's less than 2, so that, yeah, that makes sense. That's not the point P, it's the point Q, actually. It's the point Q, because there we are. Okay, just to the right of the x-axis. Okay, and then the other point would be when x equals negative 1. If x equals negative 1, y equals negative 1 plus 1 plus 1 plus 2, which is 3. So the point P is negative 1, comma 3. That makes sense, yes. Great, okay. B, concave up when d2y on dx squared is concave up, so is positive. It's going to be a linear equation. d2y dx squared is 6x plus 2. I've just differentiated that to get 6x plus 2 is positive, therefore x is larger than a negative a third. Yeah, so this P, we might just, let's it's such a hassle to draw a cubic all by yourself. I might as well just copy theirs and make it huge. A bit more reasonably sized, so you can actually read some things from it. This is the point a third, comma, I can't remember, 1 and 22 over 27, less than 2. There's a point here, negative a third, comma, whatever. This is negative 1, comma 3. And so where's it concave up? It's concave up anywhere over in this region, and that makes sense when you look at the shape. There would be a point of inflection somewhere in the middle there, which is at x equals negative a third. For what values of k are there 3 distinct solutions of the equation? Okay, so you're looking for x cubed, well, basically y equals x cubed, I can't remember the equation, plus x squared minus x plus 2, and y equals k. You're trying to sort of solve those two. Y equals k is obviously a horizontal line. I'll draw in green here. Y equals k is obviously a horizontal line, and you're looking for where does it have 3 distinct solutions. Okay, well, I think you can see that it has one solution there. Where do these two curves coincide? This is the green curve and this is the purple curve. Well, that's the purple curve there. Well, they only intersect at one point so far. Then the minute you arrive to here, when x when k equals positive a third, you're getting that second solution. But for 3 solutions, you need k larger than a third. If k is larger than a third, but then obviously you go back to there being 1 solution when k equals 3. That's the line y equals 3. 2 solutions rather when k equals 3, and then 1 solution when k is larger than 3. So you're looking for your horizontal value, if this is the line, your horizontal line, y equals k, to fluctuate between, to be between a third and 3, but not including a third and not including 3. That's basically what that's asking. K is between a third and 3. Okay, keep the questions up coming to me.